It looks like you need a bunch of if-else checks to piece together ranges, but the real trick is to treat the array as a series of consecutive runs and record the start and end only when the run breaks. You are given a sorted array of distinct integers. Your job is to return a list of strings that summarize every maximal consecutive sequence. For a single number, you just output that number, and for a sequence, you output the first number, an arrow, then the last number. For example, given the array 0, 1, 2, 4, 5, 7, the correct output would be the three strings 0-2 for -5 and 7, because the numbers form three runs, 0 through 2, 4 through 5, and the lone 7. A brute force way is to examine each element, look ahead to see how far the consecutive stretch goes, then slice that segment and move the pointer forward. You would keep building a temporary list for each run, then join the start and end into a string. This still visits every element once, so the time complexity is linear, big O of n, but you also allocate extra storage for the temporary slices, giving big O of n auxiliary space, which is unnecessary for this problem. The key insight is that you only need two variables, one to remember the start of the current run and one to remember the previous number you saw. You begin by handling the empty array case, then set both start and previous to the first element. As you iterate from the second element onward, you check whether the current number equals the previous number plus 1. If it does, the run continues, and you just update previous. If it does not, the run has ended. You compare start and previous. If they are equal, you add a single number string, otherwise you add the range string with an arrow. Then you reset start and previous to the current number and keep going. After the loop finishes, you perform the same add operation one last time for the final run. Let's walk through the array 0, 1, 2, 4, 5, 7. We start with start equals 0 and previous equals 0. At index 1 the value is 1, which equals previous plus 1, so we move previous to 1. Next value is 2, still consecutive, so previous becomes 2. The next value is 4, breaking the run because 4 is not 2 plus 1. Since start, 0, differs from previous, 2, we output 0-2. Now we reset start and previous to 4. The following value is 5, consecutive, so previous becomes 5. Next we see 7, which breaks the run. Start, 4, differs from previous, 5, so we output for -5. Reset start and previous to 7. The loop ends, and because start equals previous, we add the lone 7. The final list is exactly 0-2 for -5, 7. You'll recognize this pattern whenever a problem asks you to compress a sorted list into intervals. Look for a single pass with a start marker and a last seen value, and a mid output whenever the continuity breaks. The algorithm runs in linear time, big O of n, because each element is examined exactly once. It uses constant extra space, big O of 1, constant time, aside from the output list. Give this approach a try on the next range compression problem. And if you found this walkthrough helpful, hit like, subscribe, and check out the next video where we apply the same run tracking trick to a different challenge.